January 2, 2023, bright winter stars are in the western sky before sunrise. After sundown, 4 planets, Venus, Saturn, Jupiter, and Mars, along with the Moon are visible. The constellation Orion rises into view during the early evening hours of February each year. By Jeffrey L. Hunt. Chicago, Illinois, sunrise, 7:18 a.m. CST, sunset, 4:31 p.m. CST. Check local sources for sunrise and sunset times for your location. Times are calculated from the U.S. Naval Observatory's Mica computer program. Sunrise is at its latest time. This continues through the 10th. The length of daylight slowly increases during January to 10 hours by the end of the month. Jupiter's Great Red Spot's transit times, when it is in the center of the planet in the southern hemisphere, 6:07 UT, 16:03 UT, Jan 3, 1:59 UT. Convert the time to your time zone. In the US, subtract 5 hours for EST, 6 hours for CST, and so on. Use a telescope to see the spot. Times are from Sky and Telescope magazine. Here is today's planet forecast. Morning sky. Chart caption: early winter, Procyon, Pollux, Castor, and Capella are in the western sky before sunrise. The morning sky is without a bright planet. Some of the stars that shine during winter's evenings are setting in the western sky an hour before sunup. They are Procyon, Pollux, Castor, and Capella. Procyon is the brightest star in Canis Minor, the little dog. The name means before the dog. Find it about 10 degrees up in the west. From Chicago's latitude it rises approximately 20 minutes before Sirius, the dog star. It is the 6th brightest star visible from the mid-northern latitudes and the 4th brightest north of the celestial equator, the imaginary circle in the sky above Earth's equator. Castor and Pollux, the Gemini twins, are less than 1/3 of the way up in the west-northwest. Pollux is nearly a full magnitude brighter than Castor. In the stellar magnitude system, a lower number indicates that a star is brighter. Brightest celestial objects have negative magnitudes. Sirius, the night's brightest star, is listed at -1.5. Jupiter is -2.8. A star of 6th magnitude is at the limit of human eyesight. Each step on the magnitude scale indicates a brightness difference of 2.5 times, well 2.512. 5 magnitude steps indicate 100 times brightness difference. For those who want to perform the mathematics, it's 2.512 to the 5th power equals 100, with a 1 magnitude brightness difference. Pollux is about 2.5 times brighter than Castor. The 4th star, Capella, meaning the little she-goat, is about 15 degrees up in the northwest. It is the 4th brightest star visible from Chicago's latitude and the 3rd brightest north of the celestial equator. Arcturus, the brightest star in the northern half of the sky, is high in the south-southeast at this hour, while Vega, the 2nd brightest, is 1/3 of the way up in the east-northeast. The top 4 stars in the northern half of the sky are visible at this hour: Arcturus, Vega, Capella, and Procyon. We see them again in this orientation during late spring evenings. Evening sky. Chart caption: 2023, January 2. After sundown, Venus, Jupiter, and Saturn are visible toward the southwest. 4 bright planets are in the evening sky. Starting in the southwest at 45 minutes after sundown, Venus is about 5 degrees above the horizon. Find an observing spot with a clear horizon in that direction. Saturn, plodding slowly eastward in front of the stars of Capricornus, is about 20 degrees above the southwest horizon and over 20 degrees to the upper left of Venus. The evening star is quickly stepping eastward and overtakes the ringed wonder on the 22nd. Watch Venus close the gap each clear evening. Bright Jupiter is over halfway up in the south and nearly 40 degrees to the upper left of Saturn. These giant planets are not close together again until 2040. Venus catches Jupiter in a close conjunction on March 1. They make a spectacular pair in the western sky from February 20 until March 11. Chart caption: 2023, January 2. In the eastern sky after sunset, Mars is near the gibbous moon. Farther eastward, the bright gibbous moon, 86% illuminated, is about halfway up in the east, 10.3 degrees to the upper right of Mars. The Pleiades star cluster is 3.5 degrees to the upper left of the lunar orb and in the same binocular field with it. If you use a binocular to see the cluster, move the moon out of the field of view. The moon may leave a temporary afterimage in your vision, like that from a camera flash. To minimize that effect, move the binocular slightly to remove the moon from the view. Mars is 8.4 degrees to the upper left of Aldebaran, the brightest star in Taurus. The planet ends its retrograde in 10 nights and begins to move eastward again. It passes Aldebaran for the third conjunction in a triple conjunction series at month's end. Chart caption: Early winter, Orion is in the east-southeast, 90 minutes after sundown. The stars of Orion are rising in the eastern sky at sundown, in particular Betelgeuse and Rigel. The latter star rises at sunset in 3 evenings. The pattern is in the east-southeast about 90 minutes after sundown. After the Big Dipper, Orion is likely the second star pattern that children from the northern hemisphere learn. 3 stars that form the Hunter's Belt are easy to recognize. Pointing downward toward the horizon at 90 minutes after sundown, they indicate the direction to Sirius. Orion's shoulders are marked by Betelgeuse and Bellatrix. Rigel and Saiph dot the knees. Notice the contrast in star color from Betelgeuse to Rigel. The celestial equator splits Orion so that Betelgeuse is north of the circle, while Rigel is south. This makes Betelgeuse the 5th brightest star in the northern half of the sky, although Rigel appears about 1/3 of a magnitude brighter than Betelgeuse. Of all night stars visible from the mid-northern latitudes, Rigel is 5th and Betelgeuse is 7th. Both stars are very bright. Betelgeuse is 25,000 times brighter than the Sun, but Rigel is nearly 100,000 times brighter than our central star. Betelgeuse is larger than Rigel, even though it does not have the same intrinsic brightness. Here's how that works. Imagine 2 globes of similar size that are heated to different temperatures, one the temperature of Betelgeuse, the second to Rigel's temperature. The blue-white globe representing Rigel is very bright compared to Betelgeuse. To make the globe representing Betelgeuse as bright as Rigel, the globe must be increased in size. Bright red stars are larger than bright blue-white stars. If we could bring both stars to our solar system and put them in the Sun's place, Rigel would cover the inner solar system nearly to Mercury's orbit. The larger Betelgeuse would cover the inner solar system beyond Mars' orbit and nearly halfway to Jupiter. The orbital paths of Mercury, Venus, Earth, and Mars would be inside the star. Chart caption: 2023, January 2nd. Through a binocular, Saturn is moving eastward compared to stars in eastern Capricornus. Each clear evening, continue to note Saturn's place in the star field of eastern Capricornus through a binocular. The planet is east of Nishira, 1.4 degrees to the upper left of the star, and moving toward Deneb Algedi. Other dimmer stars that are catalogued with numbers are in the field as well. Jupiter, NASA photo. For sky watchers with telescopes, Jupiter's Great Red Spot is center stage in the planet's southern hemisphere at 7:59 p.m. CST. The Jovian Giant is over 30 degrees up in the southwest in Chicago. Observers farther west see the planet higher in the sky.